This tutorial explains some of the properties of single point calculations. Let's first of all get a molecule. Let's use aspirin as an example. When we do single point calculations, it's important to know which method that we're using, because we have to do setup prior. So if we're going to do single point calculations, we either do them with molecular mechanics, which gives only certain limited number of properties for single point, or one of the quantum mechanical methods, such as semi-empirical, ab initio, or density functional. These three methods give more results, if you like, for single point, because it gives a wave function, charge densities, electrostatic potentials, and so on and so forth that you don't get out of a molecular mechanics calculation. Anyway, so let's decide to do a PM3 calculation, single point on aspirin. So we just push the button, single point. It does the calculation, shows us the energy and the gradient, in this case the symmetry of the molecule. The molecule at this point is fairly planar, although the final optimized molecule probably is not planar. Anyway, this calculation gave us a number of things. It gave us some molecular properties, the dipole moment, the components of the dipole moment, X, Y, and Z, for example. If we choose an atom and ask for the properties, it will tell us some additional information, the charge on that atom, and so on. If we ask to see the orbitals, it will show us all the molecular orbitals with or without labels. These are the occupied orbitals in green. These are the unoccupied orbitals. If we want to zoom in on the occupied orbitals, we can do so like that. For example, put some labels on to show us their energies, and if we want to plot, say, the HOMO orbital or the one below the HOMO orbital, we just select it, say OK, and we'll plot that orbital. So this is that particular orbital, slightly different rendering while we're rotating it, and the rendering depends upon what method we choose for an isosurface. If we have an isosurface that we want Jorgensen-Salem, then we'll get that kind of rendering. Or if we want a transparent, translucent surface, we can get that as well, where we can see through the orbitals. Particularly if we have a rendering that's ball and cylinder, for example, we can see through the orbitals the atoms. Alternatively, we can ask to see some molecular properties, and if we wanted to, for example, we could plot the total charge density, electrostatic potential, and that might be mapped onto the 3D density. Let's just plot the charge density and see what we get here. I have the fineness of the grid up fairly large, so it takes a little bit longer than one might normally think of doing. Let's go back to a Garot shaded surface, and then so this is aspirin and the total electron density for aspirin. So those are some of the properties out of a single point calculation. In addition, if it's quantum mechanical, one would, for example, have the dipole moment. I guess I've lost it since I've been doing a bunch of things since I calculated this wave function. Anyway, that's some of the things that you can get out of single point calculation.